The electric motor. It transforms electricity into the powerful rotation that runs machines like saws, conveyor belts and pumps. It's so strong that it can lift objects twice its own weight 3 meters off the ground in a second flat. But the amazing thing is, there are absolutely no mechanical parts inside the motor. To create that powerful rotation, it uses nothing but magnets. Seems incredible, but how? The electric motor, it has just two main components, the stator and the rotor. The rotor is the rotating component that gets attached to machinery like saws and pumps. The stator turns the rotor by performing two astonishing feats. First, the stator generates an electric current in the rotor without any parts touching. Next, the stator turns the rotor without any moving parts. To understand it, let's take it apart. The stator is a hollow cylinder. Inside, 3 copper wires are wound in 3 different pairs of coils, threaded all around the stator's inner wall. When the motor is plugged in, electricity flows into each pair of coils, one after the other. That's key, because when an electric current passes through a copper coil, that coil becomes a magnet, an electromagnet. With these 3 pairs of electromagnets, the stator can make enough electricity flow to power the rotor. Here's how. The rotor is a solid cylinder that sits inside the stator. It has a series of highly conductive aluminium rods embedded in its surface. The stator's electromagnets must make electricity flow into those aluminium rods to power the rotor. To do that, those magnets must be in motion close to the rods. But the thing is, the coils never move because the stator never moves. Okay, so how can those magnets be in motion if the stator never moves? The stator has to simulate motion. The pairs of copper coils only become magnets when electricity flows through them. The stator never sends electricity through all 3 pairs at the same time. It switches them on and off, one after the other. They become magnets one after the other, in an overlapping pattern all around the inside face of the stator. The magnets simulate the motion of one pair of magnets spinning along the stator's inside wall. They're like ghost magnets, flying around the rotor at a rate of 30 turns per second. That's 1,800 RPM. Those ghost magnets generate electricity in the rotor's rods, without moving an inch. Once the stator provides the rotor with electricity, it uses the electricity to force the rotor to rotate, still without any moving parts. The 3 pairs of copper coils lie directly across from each other on the inside face of the stator. Each time electricity runs through a pair, they create a magnetic field. That means the electric current in some of the rotor's aluminium rods passes through this magnetic field. The current can't stay there. The force of the magnetic field pushes the current in the rods away at a right angle to the field. The current moves, so the rods move, and so does the rotor. As each pair of the copper coils magnetizes in turn, it causes a chain reaction. It pushes on the rods, and that makes the rotor move. The electric motor is a miracle at the heart of many types of industrial machinery. It transforms electricity into the rotational force that drives heavy-duty saws, pumps, and conveyor belts. And it does it using just 2 parts. Even more amazing, those parts never touch each other. They don't have to, thanks to the power of electromagnets. The electric motor, a real force to be reckoned with.